sign up for you. So this is like a dynamically changing code. For first class, actually, because we don't have yet the name list, the complete name list. So we will not actually. I think we plan not to include the first lab attendance, but we will keep the data so that we may actually use it. So, but this is just like a testing so that you kind of know the procedure. And then we will also, because we will have international students who couldn't come back, so we will conduct all the teaching in English. And at the same time, we'll be having a live teaching sections on the WeChat work group that I will kind of talk about. So the sign up will be until 10:25. I will. If you couldn't sign up for some reason, maybe due to the network, you can ask the student helper that he will help you with that. And also I have booklets that I actually doesn't really have much information. Just say that you should join GitHub Educations, but because we are moving to a new building, so I don't want to keep this. So if you want this, you can take this after the class. So it just talk about the benefits of GitHub Education. For those of you who couldn't scan, you can ask, as I say, you can ask the. Okay. So you can go to him if you couldn't sign up after the class, so that he will help you with that. So let's start. Welcome to the first lectures of the software engineering. Want to give a brief introductions of myself. For those of you who don't really know me, I am actually Chinese Malaysian. I'm born in place called Ipoh. And then if you are wondering about Ipoh, what it has and so on, it has some famous food, but I will not show it because I know that some of you may be hungry. So if I show food, maybe you will just left the classroom. So and then famous celebrity is Michelle Yeoh. She was in one of the famous movie. And then it's a place where it's surrounded by mountains. So this is kind of like the place where I live. Maybe some of you are not so interested, so I'll not go into details. And also want to go into details about teaching background, because it's actually affect how the class is going to be taught. As as you see in the first slides, actually there are, the slides is adapted from several places. So first I was doing, being a TA for the software engineering class. For those of you who, back in US, in UIUC, University of Illinois, for those of you who take OOAD, how many of you take OOAD, by the way? Quite a lot. So, just to test, do you know who is this guy, Ralph Brunson? If you have taken OOAD, I think you kind of know about him. At least know about him. So he's one of the gang of four who write the design patterns book. So used to be one of his TA, but now he has already retired. So part of the lectures actually come from that when I was a TA for software engineering class, or at least the inspirations for the projects come from that. And then after that, I moved to kind of do my PhD in a place that is closer to my home country in Singapore, in NUS. That's where I did the software testing course as a TA. So a lot of parts of this class is about testing. I think some of previous students talk about it's too much about testing, but testing actually aim to ensure the qualities. We actually also teach about static analysis tools and so on, which is actually not exactly testing, but then it's also aimed to ensure that you write good quality code. And then after that, I came here in SUSTech in 2018, so it has been 2 years, and I think this is like the third time I'm teaching this course. So, so the slides actually will be a mixture of times when I was in US, in Singapore, and then also some of the lectures I added, especially the lab sections I added by myself. And want to talk briefly about my research. You may be wondering also why it's related. It's very much related because it's about software maintenance. Like maintaining software, actually there are three kinds of main artifacts in software. There is documentations, there is the commands, like I also work on detecting outdated documentations, maintenance of tests, like I work on fixing broken tests, generating tests, and then maintaining codes, which is my recent interest is to automatically fix the bugs that people make. So I'm also actually interested in student assignments, like how to fix student assignments so that we can give student feedback. So if you encounter some problems, some bugs that you find is interesting when you are fixing the bugs, for the projects you can let me know and share with me. I will be quite interested in that. And then I want you to also think about how much time you spend in writing code. Maybe just by a show of hand, like how many of you feel that you spend the most time amount like writing code, debugging, and fixing? How many of you think that most of the time is spent in fixing, in writing code? In the first, not many people write code. Okay. How about debugging? How many of you spend most time debugging? Okay, it seems like quite a lot. How many of you spend a lot of time in fixing bugs? Okay, so a lot of time is spent in debugging, not in fixing, which is a little bit strange. So that's maybe the reason, or you may be interested in this, that what if you have a robot that can help you to debug, it can fix your code automatically. In fact, this kind of idea was implemented, done by first time in Facebook. They have this tool called SafeFix, but then this is actually integrated with their tools for testing their apps. And then we actually also inspire kind of the tools that you see before, because we actually proposed the first repair tools for Android apps, and then they actually admit that they are using similar approach as our tools for employing it, for deploying this SafeFix in Facebook. So this is actually quite relevant to all of you when you are, because you admit that you've spent a lot of time in debugging and fixing. So if you want to build the next generation tools, you want to change, revolutionize how programmers write codes, trying to improve the programmers' productivities, trying to automate boring tasks that you are repeating over and over during your development, then I hope that you can join like this kind of like an advertisement. But join like not just me, but a lot of us actually doing research in software engineering. So you can send us an email and then join my group as well. We are still looking for students. And then after that, I want to talk about the teaching staff because there are a lot of students in the class. So we actually have quite a lot of teaching staff this time. For a teaching assistant who will be teaching the lab, there will be a total of 6 labs. I think a lot of you are familiar with Hu Chunfeng, so at least he should have taught some of your class. But Wang Daxing, I think he just came, just joined us recently. I think he is in the crowd, but I don't know if, okay, so he's at the back. So he will be teaching, I guess maybe he's a bit shy, but he will be teaching one of your lab. That's, there will be some labs with him. And then with student helpers, we actually also have quite a lot of student helpers. This is sorted in the sense that there are some TAs that already served in the previous term, like Zhang Xiaowen, Li Ziqiang, Zhou Ying, and Wang Zhiyuan. And then Hu Yubing and Chen Yuheng was actually the senior students who had taken this class 2 semesters ago. I think Yuheng is somewhere in the cloud. And then he's also quite shy, so he's wearing white there. And then I think Peng Yiming is also here in the cloud. So he's also one of the student helpers. He's the master student in the university. But he also has some kind of previous experience in open source projects. And then we have some newer students, including Yan Lu, and then 2 of my master students, Ying and Lin Yuan Zhang. They are not here today, but then they will be in your lab. So they will be spreading across the 6 labs. So if you have any questions, you can ask them. And they also will be doing this Qiandao in the lab. So just to remind you about that. About the course, I think like some of you may be thinking like if you already taken Java programming and then C programming or some other programming class, what is so special about software engineering class? Software engineering class, I think, is about going from small little toy projects that you write for the programming class. Maybe you only write one class with 1 files, and then maybe like 10 or maybe 1,000 lines of code, but it's not really real world software. So we want to bring you to basically writing just one single file and knowing how the development, the software development is done in companies, and then you can actually get the experience of developing some real world and large scale software. And yet, because in a company settings, you will need to collaborate with others, or at least change other codes, knowing how to read other codes, because when you join a company, they will have some existing codes that you need to modify or fix their bugs. So this is actually bringing you to just developing toy projects to real world projects that you, I think, like actually get you prepared for if you join software companies. At least I have a lot of students telling me that this actually helped them in their interviews, especially with some knowledge about testing, and then also how to be collaborating with others in the real world software. projects. And then also because there are some previously in previous semesters, I think OOD is used to be a required course, a prerequisite for software engineering because compulsory class. So now it's just become a recommended prior class for this. I get some questions from students about this. So so you don't need to take OOD before you take this class, but because we have changed this requirement. So if you have questions about this, so I changed this recently to reflect this. So in terms of textbooks, actually there are a lot of textbooks in software engineering. We will actually use some of this, a mixture of this. I think we will stress less about design patterns because a lot of you have learned this in OAD, so we will not talk about the things that you learned before. Other than that, the Somerville software engineering book will be actually there. Actually, I have the Chinese version, I think, but didn't bring it today. So, and then you may be interested in the evaluation or the grading for the course. So the grading will be actually spread across a few parts. You see that there will be weekly lectures, tutorials that will help you to get familiar with what you need to do. And then like the submissions will be later on. I will cover how you will submit this lab tutorial. And then the main important parts you can see that takes like 35% of the course will be the projects, which you will actually be fixing GitHub issues of Java open source projects. And then it will be a group of 5, actually we allow 4 to 6 people, and then that's already put in there in the instructions. And then there will be 3 presentations, proposal, progress report, and final projects, and then there will be 2 written reports, and then also peer evaluations. We will ask about how you collaborate with your teammates at the end of the semester to check whether you have some problems collaborating. And then the final exam will be 35%. It will, of course, include anything from the class, including the lab. And then the in-class attendance will be spontaneous. We sometimes may take into account, but we will record all data and then maybe select some or maybe select all to be fair of those who attend class. So and then also at the end of the whole semester, we will have everyone come and present their projects. And some people think that maybe you don't really want to waste time in listening to others' kind of presentations, but actually we make it compulsory to attend the project presentations because this is kind of I think interesting to see what others people have done throughout the semester, so that you can kind of share or learn something from it. And then this seems to be a little bit of a bug. But the systems that we will be using actually quite, you can see that there are 3 main systems that we will be using. We will use Sakai that you are familiar with the lectures, the lab notes. And then we will have the grade books there, so you will see your score and everything in Sakai. And then we will also be using WeChat work so that we are screening the live teaching, and then we will also need to ask the international students questions in the WeChat work, but the local students couldn't, I mean, even if you answer, we will not give you the score, I mean, for that. But for interaction, you may get stickers for interactions. And then for GitHub Classrooms, you will be using it for submissions, the homework and projects, and then also you should ask questions about that in GitHub Classroom. So now I want to stop a little bit so that you can join the WeChat work. Uh, this is the WeChat work group. The WeChat work is different from WeChat. I mean, this is the official one, so I can see whenever I send a message whether everyone have written or read it before or respond. So this is more, is somehow more better in this case. Let me check whether how many people have joined. There are so many kind of joined. So wait a little bit more because a lot of people still joining. You can also try to share with your friend or invite them. After you join, you can invite your friends to join as well. I mean, like so that we can get everyone joining as soon as possible. Because later on, I want to try to ask questions so that you can answer in WeChat work. And then also in WeChat work, you can see that in the group announcement, I have put the link of Sakai there, so you can go into Sakai and then download the lectures and the lab for today. And then also, as I say, I have put in the assignments, but then you will have some time to do it. But I just put in earlier in case that some of you may want to do something before the vacations or during the vacations. So okay, I saw like over 150 people join, so I guess you have no problem joining. If you have problem joining, you can ask your students, other students to add you, or ask the student helper to add you to the group. So I want to talk a little bit about the projects. We tried this idea about fixing bugs last 2 semesters ago. Like it was during the COVID-19 where people are having the online kind of section. So we have that completely online in WeChat work. But we get quite good results. We have won the World Teachers Day Challenge. I get the prize, so you don't get the prize. But, but then I think that also shows that this competition was actually co-organized by GitHub. So it's also good news that they're actually recognizing us for this GitHub Fix-It project. And then we also have a paper that recently got accepted in one of the top ranked conference in software engineering. And then what I want to stress here is that I have uploaded the project proposal in Sakai, and then it's under the assignments folders. So you should start choosing your projects early, because some of you may be thinking, we get a lot of comments actually saying that it is very time consuming to choose the projects, choose the issues. So that's why we have it uploaded very, very early, but it is due after the vacation, so it's due somewhere around March, early March. But you can look at it how it is. You can even check the website that we have, because it has the structure or the project proposal to the progress report to the final presentations, how we were conducting it in the previous time where we are offering this. So there are plenty of kind of different things that you can refer to help you get started with the projects. In the projects, there will be a few deliverables. As I say, you need to keep track of the time, because somewhere around mid of semesters, then you will get the progress report, and then some people may forget about that. So you need to kind of remind yourself. And then the projects actually it's not just about fixing bugs, because we want to teach you a lot of things in software engineering. For example, we want to choose a software development process that is XP, extreme programming. What is XP? You'll be learning in the later on in the semesters. And then we need to document the process that you use. I think that the documentation we are writing for this class is not so much, but mainly because you are using version control systems and so on, so it will actually help you in getting more familiar with knowing what is done by others, and then so that you can collaborate with others. But we want you to make sure that you follow the process that we teach in the class instead of just randomly fix bugs, because we want to make sure that you actually trying to have good quality codes and then follow the process correctly. And then the project life cycle, it will be like the following. So it will be up to you to choose the projects that you want to basically contribute to. But the only restriction is that it should be in Java. So there are some requests that say, what if I want not to work on Java projects, work on other projects? But we don't really have a good answer, because we want you to follow actually all the frameworks or all the tools that we'll be using will be for Java. So for other programming language, it will take more time, and it will also more difficult to arrange, because if you write like 1,000 lines of Java code, the other person write 1,000 lines of C code, or even the other person like 1,000 lines of camel code. It's completely different things, like because it's not easy to judge and it may not be fair. So we want to still stick with Java. And then it's also about teamwork. So you need to form the team. Like I say, team of 4 to 6. You can actually now start to discuss with your friends or about how you are going to form this group. And then a lot of things about developing codes, but I think like it's a lot of things is about debugging, and a lot of you admit that most of the time is spent in debugging. So you are now trying to debug other people's codes. It may be more difficult. So actually it's recommended that you start with a test, and then trying to see whether you can reproduce the bugs that you're trying to fix, and then before you write code for that. And then you are graded basically based on whether you follow the process. We document all process very carefully. All instructions is written very carefully, like how many score you will get for particular parts. And then also the products, if you can develop better products, fix more codes, then it will be better. We are planning to have a collaborations with Huawei that they say that they may give some cash prizes for those who can fix more bugs. But because the application is still on progress, I don't really know whether at the end of semester or by the end of semester whether we can get the funding for that. But then the experience is that even if you don't get any cash prizes, but if you manage to make some real contributions, it will help in your making your CV look good, or at least help in if you want to find jobs in software companies, because they do values the fact that you have some contribution to some real world software. That's feedback from the previous semesters, because they get questions about giving the interviews about the projects that they developed. So this kind of motivates you to do well in the projects. And then also there are two kinds of different assignments in the course. For individual homework assignments, we will say that if you can only accept the assignments as individual, then you need to individually solve these homework assignments, and then you should have no cheating. we saw some people cheating in the previous time, and then we are able to catch all of them. So we do not actually allow you to use any resources without citations, and then also there was someone caught cheating in the final exams, which also get caught. So please don't try or like just to test the systems whether we can catch you. So I think we can catch you in any case. And then the students in the final exam get 0. The student who get caught for copying the homework assignments or sharing with others the homework assignments get 0 for the assignments as well. So you don't want to waste your effort in making an assignment that finally get 0. So this we want to stress on this because we treat this very seriously. And then in terms of course communications, as I say, we are encouraging you to use GitHub Classrooms. I think that's the logo for the GitHub Classrooms. And then you can also share, if you find some bugs in the systems that you're trying to fix, you can file a new bug report and then trying to fix that one that you find. If you have questions with Coop installations, we encourage you to post in GitHub Classrooms. You can also ask the TA, of course, and then if for any other questions, if you want to ask me, you can ask me after the class. As I said, this office may change because we are moving maybe by the end of this month. So, but you can write me emails by appointments or other way you can approach me. To show you how the GitHub Classroom is look like, at least in my view, it will be like a list of assignments, and then there will be a lot of invitation link, as you can see here. And then basically you get an invitation link, and then you accept that, and then you may you don't want to skip choosing your student ID, and then you will link your student ID to the GitHub account. So this actually has several benefits because automatically create the repository for you, and then make it easy to distribute the starter code and then to collect assignments on GitHub. So to kind of test, because I also have a limited number of these things to talk about the GitHub flow. So I want to know how many of you have not used. How many of you have used a GitHub before? A lot of people have used. So how many of you have not used GitHub? Okay, so this time actually the one have not used get prize. So because they may need to get more. Or those of you who have not used, you can take this after the class. So what this is saying is basically talking about the workflow of GitHub that you actually will be learning actually during the lab part of it, and then also throughout the semester. So basically, it has the things about creating branch, opening pull requests, merge and deploy. It's also some kind of goodies from GitHub. So since most of you have been using GitHub, but I think like not many people have created a branch or merged a pull request because those are more formal kind of usage of GitHub. So you can also take this if you want. And then how you're going to discuss through GitHub is you will actually open like kind of like an discussions. So we will have team discussions. So how it's set up is everyone is in the same organizations, and then the organizations is basically all members of the organizations, and then we are a team, and then but when you are collaborating for the group projects, you also have a team by yourself, so you can also use the same things for discussions. I think this is more useful for people, the online students, because they maybe not able to communicate so well. And then this is also easier to communicate in the sense that if you want to refer to the link and then add some things, this will serve as like the forum for the class, so you can use it for discussions. And then the expectations kind of, I know that this part may be boring, but then just want to say that you will be responsible for your own class. And then if you have too many late submissions, because you see that we have quite big portion of the score is for the assignment, so you may feel if you have too many late submissions, and then you need to pass this course to graduate because this is a required course. And then I also hope that you, because you are already now third year students, so you should be an independent student. If you have any problems installing tools, I hope that you first Google online or Baidu online if you have problems, because the things is a lot of people are using different OS, and then we cannot answer specific problems, even though we will try if we have previous experience in encountering that problems. But because we need to install a lot of different tools during the class, so this may be a problem if we handle too many different systems. And then if you have problems understanding concept, you can ask me in class or send me message, or you can ask in the WeChat group. But it's a good chance to practice your English, I think. But then maybe I will not give you an immediate answers, because for some parts I may not know exactly, especially with tool installation, you know that how many different kinds of warning you can get. But then we will give you the answers, or maybe other people have tried using it on certain machines, and then they encounter the same problems, they have solved these problems, and then we can share with others. And then this comes to the motivation for the class. Like, you may be thinking, why do I want to learn software engineering apart from what I say about viewer projects? We also have some motivations because like a lot of, at least this is some study that is done in 2015. Even though this, I think, is more on US students, but then I think this still applies globally, because it seems like what happens here is that you can see in these pictures that employers always think that students actually not very well prepared. Students are not very good in working with teams, with others in teams, stay current on technologies. I mean, it's very low percentage. They also realize that they are not very good in diverse culture outside US or here outside China, and then proficient in other language, staying current in global developments. So students actually not really good in this, not very well prepared in all this part. But then when you actually look at students' rating, that they actually have quite high self-confidence. The things that they are very good in all aspects, which I think yesterday when I have the meetings, a lot of other professors told me that they do things that students in SUSTech have very high self-confidence about. They are really good in a lot of things, but then unfortunately this is the reality. Students are well prepared in their own eye, but in reality employers really do not think so. So this is like a gap between the expectations of what actually employers thinking compared to what the student is thinking. And then we also have this kind of survey about what is the percentage of jobs that is available, even though in the US. But I think this is getting also true in China, because a lot of you are thinking like, what is so good about being a software engineer? It turns out that the highest percentage of open AI jobs in Glassdoor, which is one of the job kind of applications website, the things that the highest highest percentage is the AI software engineer. So if you say that you want to do AI and then you say that then I want to be prepared for being an AI kind of related jobs. But then you see that there are a lot of things that then needs not just AI, they want you to be an AI software engineer. So this is also motivations for learning software engineering. For those of you who are wondering what is AI software engineers, actually requires several parts. So what AI software engineers is doing is they have this data analysis, data scientists kind of people, they're trying to do the data analysis, build the models, and then there is also some business partners, the one who are handling business, like Scrum masters, they're trying to manage projects, manage the meetings, and then make sure all targets meet. And then there is also data architects that are trying to develop, construct, test, and maintain architectures. But AI software engineers needs to kind of collaborate with these three partners, like data scientists, business analysts, and then also data architects, to ensure that when you are developing the software, you need to meet the business objective, and then also you want to make sure the final product is scalable and then also secure. So, so basically, a few key things like here in AI engineers that we'll be doing will be looking at infrastructures as code, and then continuous integrations, and then automated testings, and then also API and also MVP applications, integrations and developments. And then what is unique is about all of this kind of things that AI engineers need to do is actually concepts that will be taught in class. Even though the concept itself is quite, I think, quite simple, but then this actually also motivates like why we need to learn software engineering. And so why is this class also important? If you maybe for some of you who will be actually doing some other parts, like other kind of career path. So like maybe just out of curiosity, how many of you thinks that you will become a developer or software engineers? I get the show. Okay, so one student, okay, 2 students. So maybe 3 students in the class think that they will want to be software developers and engineers. And then how many of you think that you will go to grad school after that? You will do either a master or a PhD. How many of you think that? Okay, also one. Okay, also the same people. And then how many of you think that you are going for overseas studies? Okay, so I don't know what happens. Either how many of you are undecided? Like don't know what you are going to do. Okay, so at least, so a lot of people are undecided. So I think for undecided part is even better because this class actually is helping you to prepare for all these aspects, because like as software developers and software engineers, is I think this I don't need to say that this will be important, but for grad schools, if you have some experience in involving in some real projects, and then some of the projects that you choose actually could come out of research, so then it will actually be good for grad school as well. For overseas studies, because you contributing to projects where actually is well recognized globally, so that will also help in overseas studies. So for those of you who are undecided, you can also take these opportunities to kind of decide like whether you like writing codes, whether you like contributing to open source projects, whether you like going to grad school after being interested in some projects that you find that you want to do more research on. So all of this is possible. There are some topics that we study in software engineering, including process. That is the most important part. Because I think a lot of you, when you are writing your own Java code, you don't really follow any process. You just write codes and then change the code, debugs, and then hope that you finally pass the test cases in the OJ, and then that's all. I think that's how you develop. But then there is a process that you want to be learning, or if you later on work in the companies that also have some process that they are using. And then I think the other things is about tools, because we try to help developers in making the software developments, debuggings, and then maintaining the software more effectively. That's why there are a lot of tools. And then these tools are built upon some techniques. So there are a lot of some techniques that you'll be learning how it works. And then we also have learned some models of software development. I think this not so much that we are learning. And then also trying to modeling of the development software. I think these two at the end will be more covered in the software testing class rather than software engineering class. For the software process, you may be thinking what is the process means. So according to the IEEE standards, it's a set of activities that is performed towards specific purpose. And then basically it's steps that one group follow to develop software. So it's basically you try to use the same process. And then the one that we use in the class is SSA XP, Extreme Programming. We will be learning this later in the semesters. And there are actually a lot of other software development process that you may be actually already learned some of this in the OAD class. One of the key software development process is Agile. So, and then extreme programming is also part of Agile. And then Scrum was also used by some companies. I heard that some company changed to Scrum. It's more flexible. And then there is a theoretical kind of software development process. I don't know whether you have learned about this. That is waterfall model. We will talk about this or give a brief introduction or review about this later in the class. And then there are also other more formal software development process that actually I'm also not very familiar with, but there is Rational Unified Process, RUP, and Clean Room. And then there are also some more distributed and open source kind of process like Quasar. So there are a lot of, you can see that a lot of terms here for software development process, because different companies actually choose different software development process, and even within the same company, maybe different teams choose different development process. And if you join a company and then people tell you that they're using Scrum, and then you start saying what is Scrum, and then there were things that maybe you didn't really learn software engineering, or of course extreme programming actually not so much used in practice, but then it's part of Agile, and Agile development process is actually quite widely used for a lot of companies. And then I want to also talk with, it's almost like a story. So this is like a fable of chicken and the pig. So one day, one pig and then one chicken, they are walking down the road. And then the chicken say, hey pig, I was thinking we should open a restaurant. And then the pig say, maybe, what should we call it? And then the chicken responds, how about ham and egg? And then the pig thinks for a moment and say, no thanks, I would be committed, but we will be only involved. So this is not just a simple story. I mean, it's actually about one of the development process about these two roles in here. you can see that in these stories, there is pig and the chicken, and then in the things that we are proposing, ham and eggs. Even though it's also a type of food, but I think most of you don't really like ham and eggs so much, so maybe it's okay. But because in this ham and egg, the main ingredient is ham. Ham is come from pig meat. So to get the pig meat, you need to kill the pig. But then to get the eggs, you don't need to kill the chicken. So that's the moral of the story is the chicken is being involved. He just needs to give the eggs, but then the pig is committed. Like he needs to basically get killed and then have this restaurant. So this is the moral of the story. So it's actually also the roles in Scrum. The process that we will be, okay, since we reached the first part of the lectures, I will let you take a break and then we will come back. And you can also talk to the student helper if you couldn't sign up just now for the lectures.
签到了，那贴在哪儿了？贴那不能举那手或者表示自己。这个。